Light travels incredibly fast, moving at an astonishing speed of about 299,792 kilometers per second. It's the fastest thing in the universe, outpacing everything else by a significant margin. But even light takes time to travel vast distances, crossing the immense voids of space. Consider the sun, our nearest star, a colossal ball of burning gas. It bathes us in warmth and light, providing the energy necessary for life on Earth. But did you know that the sunlight we see and feel started its journey over 8 minutes ago, traveling across the vast expanse of space? Yes, it takes about 8 minutes and 20 seconds for light from the sun to reach Earth, a journey that spans approximately 150 million kilometers. That means when you look up at the sun, never directly of course, you're seeing it as it was in the past, a snapshot of history. You're looking back in time, witnessing the sun as it was 8 minutes ago. This 8-minute journey is a cosmic ballet of light and gravity, a dance that has been ongoing for billions of years. Light, made up of tiny packets of energy called photons, streams out from the sun in all directions, illuminating our world. Gravity, the force that holds our solar system together, keeps Earth in orbit around the sun, ensuring this beautiful dance continues. Earth doesn't orbit the sun in a perfect circle. Instead, it follows an elliptical path, like a slightly squashed circle. This elliptical orbit means that Earth's distance from the sun changes throughout the year. Sometimes Earth is closer to the sun, and other times it is farther away. At its closest point, called perihelion, Earth is about 147 million kilometers from the sun. This usually occurs in early January. Conversely, at its farthest point, called aphelion, Earth is about 152 million kilometers away. This typically happens in early July. This variation in distance affects how long it takes sunlight to travel from the sun to Earth. When Earth is closer to the sun, sunlight has a shorter distance to travel. It arrives a bit quicker, taking about 8 minutes and 10 seconds. However, when Earth is farther from the sun, sunlight takes a bit longer, about 8 minutes and 27 seconds. This difference might seem small, but it is a fascinating aspect of our planet's journey around the sun. So the next time someone tells you it takes 8 minutes and 20 seconds for sunlight to reach Earth, you can impress them with your knowledge. You can explain that it's an average time and that the actual time varies slightly throughout the year due to Earth's elliptical orbit. This knowledge not only highlights the dynamic nature of our solar system, but also deepens our appreciation for the intricate dance between Earth and the sun. Understanding these details helps us better grasp the complexities of our planet's relationship with the sun, and the delicate balance that sustains life on Earth. The 8-minute journey we've been discussing is only the final leg of a much longer journey for sunlight. This journey is far more complex and fascinating than it might initially seem. You see, photons, those tiny packets of light energy, aren't born on the sun's surface. Their story begins much deeper in the very heart of our star. They originate deep within the sun's core, where temperatures and pressures are unimaginable, reaching millions of degrees and crushing densities. In the sun's core, hydrogen atoms fuse together to form helium, releasing tremendous amounts of energy in the process. This nuclear fusion is the powerhouse of the sun. This energy is what powers the sun and allows it to shine so brightly, providing the light and warmth essential for life on Earth. Photons are born from this nuclear fusion, but their journey to the surface is anything but straightforward. It's a long and arduous path. Photons constantly collide with other particles in the sun's dense interior. These collisions are frequent and chaotic. They get absorbed and re-emitted, bounced around like tiny pinballs in a cosmic pinball machine. This process is incredibly random and unpredictable. This chaotic journey is known as the random walk. It's a fitting name for such a tumultuous path. It can take a single photon tens of thousands, even hundreds of thousands of years to escape the sun's interior and reach its surface. Only then can it begin its swift 8-minute journey to Earth. Section 4. Time dilation, a wrinkle in space and time. Einstein's theory of general relativity tells us that gravity affects not only matter and energy but also time itself. The stronger the gravitational field, the slower time passes. This phenomenon is known as time dilation. Now, the sun has a much stronger gravitational field than Earth. This means that time passes slightly slower on the sun's surface than it does on Earth. So, technically, the 8 minutes and 20 seconds we measure for sunlight to reach Earth is slightly shorter from the sun's perspective. However, the difference in time due to gravity is incredibly small. We're talking about fractions of a second over the course of 8 minutes. While fascinating from a scientific standpoint, this time dilation has no practical impact on our daily lives. Section 5. Light, a cosmic time machine. Light's finite speed, while incredibly fast, has profound implications for our understanding of the universe. It means that whenever we look at distant objects in space, we're seeing them as they were in the past. Light from these objects takes time to reach us, so we see them not as they are now, but as they were when the light we're seeing left them.